And here in section 7.4, we're going to check out these sum and difference formulas. And what we're going to do in this whole section is use these sum and difference formulas to evaluate trig functions, verify identities, and solve trigonometric equations. Now, when you first look at these sum and difference formulas, they look pretty intimidating. But once we break them down, you're going to see they're not too bad. The first two are sign formulas. The sign of a sum, we're adding a couple things together, and the sign of a difference, we're subtracting. And if we look at the formula, what these are equal to, the sign of a sum is we take the sign of the first thing, u is the first thing in here, the sign of the first thing, times the cos of the second, the v, and then we add the cos of the first plus or times the sign of the second. And if we look at the formula right below it, the sign of the difference is basically the same thing, but here we are subtracting two things. And we take the same formula as above, and we just change that sum to a difference, a subtract. The cos formulas are pretty similar. We have the cos of a sum and the cos of a difference. But if we look at what this is equal to, the pattern changes slightly. In the sine formulas, it was sine cos plus sine cos, or cosine. Now it is cos of the first thing times the cos of the second, minus the sine of the first, times the sine of the second. And here for cosine, when we're doing a sum, this other part of the formula is a subtraction. And when we do the cos of a difference, when we're subtracting here, it becomes cos of the first times cos of the second, plus sine of the first times sine of the second. And there's also a formula for tangent. Tangent of a sum is the tan of the first thing plus the tan of the second in the numerator, and then the denominator is 1 minus tan of the first times tan of the second. And when we change that to the tangent of a difference, there's only a few slight changes. Here it's tan of a difference. Now the numerator has a subtraction in it, and our denominator has addition. So when we change from tan of a sum to tan of a difference, we just flip these signs to negative positive. And if you're still a little confused when we take one of these and actually start to apply it, you'll see where all this falls right into place. So here in example 1, evaluating a trig function, find the exact value of sine of 1/12 pi. If we go to our unit circles, 1/12 pi is not one of our commonly used angles. So that's not just going to be a point on the unit circle. And we got to think to our fractions. On the unit circle, we have radian measures. We have a 1/6 pi. We have a 1/4 pi, a 1/3 pi, half pi. How can we get a 1/12 by adding or subtracting two of the fractions that we do already have on the unit circle? Well, a 1/12 is the same thing as a 1/3 minus a 1/4. So a 12 pi is the same thing as a 1/3 pi minus a 1/4 pi. So that also means that the sine of a 12 pi is equal to the sine of a 1/3 pi minus the sine of a 1/4 pi. So what we have here is, and this is, back that up, not those subtracted, it's the sine of a 1/3 pi minus a 1/4 pi. So this sine of our unknown angle, or never before used angle, becomes the sine of this difference. And this is going to fit the second formula here. The sine of a difference is the same thing as the sine of the first times the cos of the second, minus the cos of the first times the sine of the second. So we have to take these angles here, a 1/3 pi and a 1/4 pi, which are on the unit circle, and break this down using that difference formula. So when we start to follow the pattern in the formula, we're going to get, this turns into the sine of the first thing, or the sine of a 1/3 pi, times the cos of the second thing, the cosine of a 1/4 pi, minus cosine of the first thing, pi over 3, times the sine of the second, pi over 4. Now each of these pieces, individually, we can find the value on the unit circle. So the sine of a third pi is root 3 over 2. The cosine of a quarter pi is root 2 over 2. And then we subtract. Cos of a third pi is 1/2. Sine of a quarter pi is root 2 over 2. And since we're multiplying here, root 3 times root 2 is root 6. Over 2 times 2 is 4. And then minus 1 times the square root of 2 is square root of 2. 2 times 2 is 4. And since we already have a common denominator of 4, we can combine our numerators over that common denominator, root 6 minus root 2. Do not think that root 6 minus root 2 is the root of 4. Those are completely distinct. Those are irrational numbers, decimals, and we can't just subtract what is under the radicals. We have to leave it in this form. And you know, this is the exact value of the sine of a 12th pi. When you need an exact measurement, you know, you want to keep it in radical form. You don't want to find the decimal and round it off. So let's do one with degrees in it as opposed to radians. We want the exact value of the cos of 75 degrees. 75 degrees is not on our unit circle, but remember the angles that we are getting real familiar with are 30 degrees, 45, 60, and 90. How can we break 75 up into either a sum or a difference of two of these numbers? Well, 75 is 30 and 45 added together. So the cos of 75 degrees is the same thing as the cos of 30 degrees plus 45 degrees. And now we're going to go to our formulas. We're doing the cosine of a sum, the cosine of two things added together. So we're looking at this formula. So we're going to do the cos of the first times the cos of the second minus the sine of the first times the sine of the second. So let's start plugging those in. We're going to have the cosine of the first thing, the cos of 30, times the cosine of the second thing, 45. And then we're going to subtract the sine of the first thing, 30, times the sine of the second thing. It's the sine of 45. And now each of these individual pieces are values that we can find on the unit circle. The cos of 30 is root 3 over 2. And we're going to multiply that by the cos of 45, which is root 2 over 2. And then we're going to subtract the sine of 30 is 1/2. And the sine of 45 is root 2 over 2. And we multiply across here and get the square root of 6 over 4. Minus here we multiply straight across and get the square root of 2 over 4. And again the common denominator is 4. And we have root 6 minus root 2, which we leave as root 6 minus root 2. Those are two irrational numbers being subtracted, so their difference is going to also be irrational. Now another way to solve this problem is to use the fact that 75 is 120 minus 45. So instead of adding 30 and 45, we could have got the same 75 by subtracting. And we could have used the cos of a difference formula. And when it all boiled down, we would have the exact same answer. Now example 3, we're going to have to work a little more. Find the exact value of the sine of the sum given this information. The sine of u is 4/5, where u is between 0 and 1/2 pi. That means we're in the first quadrant, quadrant 1. And cosine of v is negative 12/13, where v is between quarter pi and pi, which means we are in the second quadrant. So if we try to go to our formula right now, the sine of the sum is sine of the first, cos of the second, plus cos of the first, sine of the second. Well, the sine of u we have is 4/5, so this sine of u is 4/5. Times the cos of v, well, cos of v is right here, negative 12/13. Plus the cos of u. We don't have the cos of u. And we're also going to need the sine of v. We have the cos of v, but not the sine of v. So what we're going to have to do is a little scratch work over here in our drawings to find these two values to complete using this formula. So sine is 4/5, and we're in the first quadrant. So here's angle U. Our triangle is drawn in the first quadrant. Sine is opposite over hypotenuse. So from this angle U's perspective, our opposite side is 4. Our hypotenuse is 5. And we're going to need this adjacent side to find cosine. Cosine is adjacent over hypotenuse. So we need this missing side, and then place that missing side over the hypotenuse for the cos of U. And if you recognize the 4 and the 5 being the hypotenuse, you might remember that we have a 3, 4, 5 triangle, or you could do Pythagorean theorem. X squared plus 4 squared equals 5 squared. Solve for x, and you're going to find the values 3. So the cos of angle U, here's angle U, cosine is adjacent over hypotenuse, or 3/5. And the last piece of the puzzle is sine of V. Well, we know the cosine of V, and we know the quadrant. We lie here in the second quadrant. Cosine is adjacent over hypotenuse, so this is going to be 12, and this side of the triangle, the hypotenuse, is 13. Again, we could use Pythagorean theorem. 13 squared is equal to 12 squared plus x squared, and we would solve that to find the missing side is 5. And the sine of V is opposite over hypotenuse, or 5/13. Okay, let's multiply straight across. We're going to get here negative 48, and 5 times 13 is 65, plus 15 65ths. And we have a negative 48 plus 15, which is negative 33 65ths. And now we're ready for some practice problems, just like the examples. Pause the video, try the practice problems, then fire the video back up and see if you got the answers correct. So let's see here in the first one, example 7, we want to find the exact values of a couple of expressions here. And I think let's just do the first one. So the cos of a sum. The cos of a sum, if we go back to our formulas, the cos of a sum is cos of the first, cos of the second, minus sine of the first, sine of the second. So, if we start to break that down, it's going to be the cos of the first thing, 1/4 pi, times the cos of the second thing, 1/3 pi, minus the sine of the first thing, 1/4 pi, times sine of the second thing, 1/3 pi. And we go to our unit circles, and we get the cos of a 1/4 pi is √2/2. Cos of a 1/3 pi is 1/2, minus sine of a 1/4 pi is √2/2. Sine of a 1/3 pi is √3/2. And multiplying straight across, we get √2/4 minus √6/4. And with the common denominator, we'll combine those terms, and our numerator will be √2 minus √6. And, let's skip B. Let's check that out. I'm going to save this answer here. Off to the side, I'll put it right underneath this. And now it's asking us to find, we got the cos of a sum, but what about the cos of the first thing plus the cos of the second thing? How different is that? Well, the cosine of a 1/4 pi is √2/2, plus the cos of a 1/3 pi is 1/2. If we add those together, we're going to get √2 plus 1/2. And to make it a little more comparable to what we have here, let's multiply through by 2, numerator and denominator, so that our denominators match. So here the denominator will be 2 times 2 is 4. And if I distribute this 2, I'm going to get 2 roots of 2 plus 2. So the cos of a summed quantity and the cos of the first thing plus the cos of the second thing, we can see is pretty different. Here we just have a root of 2. This is twice the root of 2. Here we just have a 2, and here we have a root of 6. In number 11, we're looking at the sign of a difference. So if we go back to the formula page, the sign of two things subtracted. And 135 is not on the unit circle at all. So let's do the subtraction in the parentheses. The sign of 135 minus 30 is 105. From our unit circle common angles, how might we find 105 degrees? Well, that's going to be the sign of 60 plus 45. 60 plus 45 is 105. So now we're ready to go to the formulas. We have the sign of a sum. And that's going to be the sine of the first thing, the sine of 60, times the cos of the second, the cos of 45. And then we add to that the cos of the first thing, 60, times the sine of the second, 45. We're off to the unit circle. The sine of 60 degrees is root 3 over 2. Cos of 45 is root 2 over 2, plus the cos of 60 is a half, and the sine of 45 is root 2 over 2. So I see right now our denominator will be common. It's going to be a 4. And we're going to have our numerator terms summed. Root 3 times root 2 is root 6. 1 times the root of 2 is root 2. So we have root 6 plus root 2 over 4. So that's the answer to part A. Now if we just look at, well, let's do this part. Let's figure this all out on a calculator and see what it looks like as a decimal. So let's see here. Let's get the decimal equivalent of the first one. Where's our square root button? The square root of 6 equals 6 square root plus 2 square root equals, and then we're going to divide that by 4, and we get 0.9659. And if we compare that just to this, let's see what we have there. Clear that out. 135 sine, 135, we are in degree mode, 135 sine minus 30 cos equals negative 0.1589. Negative 0.1589. And just the fact that they're positive and negative is a huge difference as to why the sign of this difference is different than the sine of the first minus the cos of the second. All right. Last one. This one's going to require a little bit more work, like that last example. Slide this up here. With our given information, the sine is 5/13, cos is negative 3/5, and we know that both angles lie in quadrant 2. So I can just draw a couple quick. This quadrant 2 here. And for the first one, we know the sine of u is 5/13. So this is angle u. Sine is opposite over hypotenuse, 5/13. And because this is on the x-axis, this is going to be a negative value. Here our y value is positive. Hypotenuse is always positive. Pythagorean theorem is going to tell us that this is negative 12. And for angle V, here's angle V. And we know that cos is negative 3/5. Cosine is adjacent over hypotenuse. Negative 3 is on our x-axis. 5 is the hypotenuse, and if you recognize here again we have a 3, 4, 5 triangle. So this missing side is 4. We should have everything we need now. Sine of a sum is the sine of the first, sine of u times the cos of the second, v, plus the cos of the first u times the sine of the second thing, v. Some of these bits we already have. The sine of u is 5/13. The cos of v is -3/5. And now we're going to have to go to the triangles that we created. The cosine of u. Cosine is adjacent over hypotenuse, or -12/13. And we're multiplying that by the sine of v. Sine is opposite over hypotenuse, or 4/5. So here on the left, we're going to have a numerator is going to be -15, denominator 65. And then plus, here our numerator is going to be a -48, denominator 65. And we add those fractions together. Denominator's already common, 65. -15 and -48 is -63. -63 65ths is the exact value of sine of the sum with our given information. Homework for this section, page 572, these problems.